Good afternoon, ladies and gentlemen. Baptist Honors. Good to have everybody here today. We just had an excellent session of singing. I appreciate everybody participating in that. So what happens is, what we're looking for is, it's not that one. Okay, it's this one here. Okay, we're going to be working on more characteristics of function graphs, and we already have been working on that, right? So we talked about characteristics of function graphs. Which ones have we talked about so far? Domain, range, and
intercept.
and behavior.
Yes. No, I said it. Give her a star. I said it. I said behavior, not her. What do you mean? Don't point at her. That was me.
I gave her the idea.
I know you want to start, but don't try that hard. Jayla's on first.
Okay, good? Yeah. Okay. Okay, remember we talked about healthy envy today?
Don't envy my answer, Maddie.
Okay, be healthy envy. All right. What we're going to do is we're going to pile on and get some more characteristics of functions today. We're going to talk about where functions are positive and negative. Yes.
Can you go back to the very first one?
This one here?
Yes.
And really, it's more characteristics. So you watched yesterday's?
Yeah, just a little bit.
A little bit, yeah.
Yeah.
So we did started talking about this yesterday a little bit, yeah. Well,
Okay,
good.
it's all good. We're good. To the next
Yeah.
slide.
I saw that.
So anyway, we're going to have more characteristics of functions today. And I'm going to go over these pretty quickly. So I want to start into the exercise set today. So we're going to talk about first positive, negative intervals, then increasing, decreasing intervals. We'll talk about turning points, and we'll talk about average rate of change, and go over quick examples of each. So we come over here, and then what are some attributes of function? That's fine. So what we have is this graph here. So you see this graph here that's kind of a sawtooth graph, right? Graph is increases here, goes up from -1 to 1, and just kind of oscillates between -1 and 1, all the way as the x values increase between 0 and 11. Okay, everybody sees what that is?
Yes, sir.
Okay, and so really these are the kind of lead. The values of the function on the interval from 1 to 3 are positive or negative, so you have to choose. So you look at this interval, and when you talk, so intervals, when you talk about intervals, what are you talking about?
The graphing point.
Actually, intervals mean x values.
Sorry.
So the intervals are the x values. So what this is asking is, if you look at the x values between x equals 1 and x equals 3, are the values of the function on the graph positive or negative? Positive, right? And one thing you can look at is they're positive because they're sitting right here above the x-axis, right? So positive is our answer for this one. And now for B, the values of the function on the interval from 8 to 9 are positive or negative. So here we are, 8 to 9. Are the values positive or negative?
Positive.
They are sitting here below the x-axis, right?
They're negative.
Negative, yes.
So negative. Okay? Questions about that?
No, sir.
Okay. Now next, we go on here. We're going to talk about increasing and decreasing intervals. And what I did is I took the snapshot of the same, I clipped out the graph here. And so see, the given function is, we're talking about increasing, decreasing here. And so when you look at increasing, decreasing, you have to go from left to right. It's like, if you remember here, we talked about like slope dude, right?
Yeah, that's
So which way does slope dude ski?
downwards.
No, he skis from left to right.
Oh, yeah.
no,
He's
wait.
downwards. He makes it S.
What'd you say, Charlie?
S as it's best.
What'd you say? Boring S? Well, slope No, so slope dude actually goes left to right. So he just goes in one direction, goes left to right. And it's the same thing when you evaluate a function, you're going from left to right. So slope dude is going from left to right. And so what's happening? If he's going up the mountain, that's increasing, right? If he's going down the mountain, it's what?
Decreasing.
Decreasing.
Obviously, that's what he's.
And if he's going flat, he's doing what? Slope of 0, okay? And then if he falls over the cliff, that's slope of?
Negative.
Slope of undefined, okay? Slope of undefined, thank you.
Oh, it was undefined. I thought it was negative. I was like, oh.
So anyway, we're going back to Algebra 1, slope dude. Okay, so now, and what you're doing is you're just kind of looking, so the given function is increasing, decreasing as x goes from 2 to 4. So here, as we go from 2 to 4, is the function increasing or decreasing? Okay, I'm looking at the things going down, right? So as we go from 2 to 4, we're coming down from here to here. So decreasing is our answer for this one, right? What about the interval from 4 to 6? Yeah, increasing, because that's this thing right here, and we're going up over this interval, so we are increasing on this interval right here. All right? Evaluating again left to right as we look. Just go graph left to right. Okay, now we're talking about another thing called average rate of change. Okay, so average rate of change, is there anybody who has an idea of what average rate of change is related to that we've talked about, or you don't remember hearing this class? I don't think we've talked about it much in this class. We've talked about it a little bit on the SAT problems today, but okay, what this has to do with is the rate of change formula that we've talked about, you might be most familiar with, is this one right here. You remember this one? Oops, I have to write it down right first. Ever seen this? Man, I'm just like, I don't know what's happening here to me. There we go, I got it right finally. You ever seen something like that? Yeah, Michelle says. Yeah, that's what it is, like slope formula. And I want you to consider another version of the formula. It's this. And I like to call it, and we use this one a little bit more in calculus especially, average rate of change equals f of b minus f of a over b minus a. Now, does anybody have any idea what that is? Or does that look crazy to anybody?
A little bit.
A little bit, right, yeah, it does.
It looks intriguing.
You don't know what it is, yeah. So that's fine. I'll tell you what that is. What it is, when you have an interval here, you consider the points that you're considering here would be like, the last point value would be b, and 0 would be a. And so when you work out using this formula, you have f of b minus f of a, and so it tells you b is 2, right? So what's going to be f of 2? We go to x equals 2, what's f of 2? 1. So we have 1, and then it's going to be minus a, so minus, and what is f of a? What is f of 0? Right, we're looking for f of 0. What's f of 0? Negative 1. So we have 1 minus negative 1 over b minus a. So that's 2 minus 0. So what's that going to be? What's 1 minus negative 1? 1 minus 2, right? So we have 2 over 2, which equals 1. And one thing I didn't write, so it might not be clear, so it's going to be, again, I'm going to put f of 2 minus f of 1 over 2 minus 1. You see that's what that is? 2 minus 0, excuse me. F of 2 minus f of 0. Did I confuse you too much? F of 2 minus f of 0 over 2 minus 0. That's what that is. Are you okay with that?
Yes, sir.
So what it is, it's average slope. So you just take, if you, also you could say, you could do it like this. You could say x1, or see that's x2, right? x2 is equal to 2, and y2 is equal to 1. And over here you have x1 is equal to 0, y1 is equal to -1. And you could take these points and put them in this form too, right? Back in this one. And are you going to get the same thing? Now, an average rate of change, now, it so happens that average rate of change happens to be the slope of this line segment between the 2 points, right? But an average rate of change, what if instead of this line segment between the 2 points, what if we had something that looked like this instead? Now that's not a line in blue anymore, is it?
No.
But is the average rate of change will still be the same?
Yes.
Yeah, it'll still be the same. So it kind of doesn't matter what happens between the points. The average rate of change is still going to be good based on input and output values. All right? So, so that's average rate of change. Next, we have something that we call turning points. And turning points are points where the function changes from increasing to decreasing or from decreasing to increasing. They're turning points. And so any place there is a turning point that goes from increasing to decreasing, there will be a maximum value. Any place there is where a function changes from decreasing to increasing, there will be a minimum value. So those are turning points. And then the question is, how many points does the given function change from increasing to decreasing? At how many points are we changing from increasing to decreasing? Okay, here we're changing from increasing to decreasing. There's 1, right? Here we're changing from increasing to decreasing. So we have that, right? And then we're changing another time from increasing to decreasing. So what's our answer here? 3. So we have these 3 turning points change from increasing to decreasing. So that's what they are, right? And next, we look over here and ask the question, what is the function's maximum value at these points? And I have the graph down here. What's the function's maximum value at these points? 1. Okay? And then the next question, at how many points does a given function change from decreasing to increasing? 3. I count 2 points where we're changing from decreasing to increasing.
If it's 1, 2, 3. Oh, no, the first one. Your count the last one.
Okay, so here we're changing from decreasing to increasing. Here we're changing from decreasing to increasing. And I don't, even though we have these other minimums here, these ones on the bottom are the only ones that will qualify as turning points, right?
Right.
And then ask, what is the function's minimum value at these points?
-1.
Yeah, -1. Okay, good. And then the next question, how many x-intercepts does the given function's graph have? How many x-intercepts do we have here? What is an x-intercept?
When it's on the x.
Yeah, and so what it is, it's where the function touches or crosses the x-axis, right? So how many x-intercepts do we have here?
6.
Count 1, 2, 3, 4, 5, 6. Looks like 6 to me. And identify the zeros of the function. Now this is an instance, we've talked about different types of different notation. But this is a function. When you're asked for values like this is one where set notation really comes in handy. Because what can you do with this thing here? Well, you can just write down what the x values are, right? What are they? 1, 3, 5, 7, 9, and finally 11. And one thing, the way it's being asked here is if this number is right here, how many values should we see here? 6. And are there 6 there? Yeah, so we're good, right? And then, so we have that. Identify 3 different intervals and have same amount of change. No, I don't want to do that. And sketching from a verb, we're going to do some scales where we go ahead and look at graphs. And I don't want to get into too much detail of that. We're going to go over some graphs. And I'll just worry about that when we come to the exercises. They're pretty self-explanatory. So what I want to do today is I want to start on this exercise sheet that asks us some things about that. So we'll kind of just get started on this today. So Emily's going to hand these out for us. And we may just be able to do 1 through 3 today. So I want you to look at number, so we went over notes just now on this, right? So I want you to look at these first 3 questions. That might be as far as we get today. So I want you to consider this. So you have this graph, right? You have this curved graph starting at t equals 0, going all the way up to t equals 18, and then it's just kind of curving. You have a whole bunch of stuff on there, right? And you can probably see up there my resolution of my graph paper is probably better than yours, right?
Yes.
Absolutely.
It's just copying limitations. It just doesn't copy as well on yours. So it's not some kind of a plot to deprive you of educational resources. That's just what happens, right? So anyway, remember we talked about interval. We were talking about x values, right? And so for question number 1, on what intervals is the function decreasing and what intervals the function increasing, we're going to call on somebody who's going to help us understand that.
They're going to spin the circle?
Yeah, so Emily's going to do that now. Lily.
I don't think that it actually spun to me.
It did.
Okay, Lily. Get
Go on
it.
the board. She just.
Come on, Lily.
So what I'm going to do, so you don't have a very good idea on this, Lily?
When it's decreasing,
Uh-huh.
going down.
Yeah, okay. I have an idea, right?
Okay.
This is my idea. This is what I did in 6th period, so I think it's a good idea for 7th period. What I'll do is I'm going to go ahead and explain the interval where the function is decreasing. Then after I do that, you'll be able to understand to explain where the function is increasing. How's that?
Okay.
All right, good. That's exactly what I did with Eli in 6th period. So anyway, so on what interval is the function decreasing? So I'm going to say function is decreasing. And I'm going to say on the interval of, we're decreasing all the way from x equals, or in this case, t equals 4. And we're decreasing all the way to where t equals 13. And I had another thing, another person who was helpful in 6th period was Balin, said, or you could write this instead in interval notation, or in inequality notation, as 4 is less than t was less than 13.
Why'd you do 13? I thought it would be 3, but it's not.
Well, it looks like 3, yeah, so I misread this. Thank you, Madeline, who else?
So really?
Yeah, 3 to 13. We changed that. I just didn't read it exactly right. Yeah, I hope you weren't confused by that, but that's, is 13 right? Yeah, it looks right. And the 3 is right here. Okay, now it looks good. Yeah, the 4 is not quite there, but 3 is. Okay, good. Thank you for catching that. Okay, Lily, so on what intervals is the function decreasing?
Would it be 13, 18, or 13,
So,
17?
Lily says function is increasing on, we say on the interval, it's going to be 13 to, are we talking about x values or y values? 13, x values, so that's going to be x is what? 18, right? Is the function increasing anywhere else? From the beginning? Okay, so in the beginning. So also in the beginning, so we're gonna go like this, 0, 2, 3. Okay, I don't know if I've said this, have I told you that U means union? Have I told you that? And I told you that that's President Lincoln's favorite mathematical symbol?
Yes.
Yeah.
And you laughed at it? Very good. So you laughed at it.
Remember I get to. You okay, Brian?
Okay. So problem 2 here, identify any maximum values and minimum values. Now I will tell you, if you look over there where Chelsea is, you see that little crossword thing, where, what? That's what we're talking about. Okay, the what is the values. The where is the x value, right? So where it happens, in this case, they use time, right? Sometimes you'll see when instead of what. So it could be instead, I'll write it up here. Instead of where what, here you have time, right? So here, what you have is you have a when what. You see that? So here's what your x values is. In this case would be your time, right? And in this case would be what values they are. So identify any maximum values and minimum values. Go ahead, Emily.
I feel like I should have gotten this star because I told you that it was 3. Don't you think?
Pardon me? Okay, yes, yes, I stand corrected.
I don't know which one this is, but it's one of them.
It's this one right here.
Oh.
Okay, so just put on spot 2. That's what you get for mentioning that. No, I'm just kidding. Go ahead. Identify any maximum values and minimum values.
What is the... Would it be 3 and 13 or something?
3 and 18.
Oh, 3 and 18. My bad.
0 would be the negative.
0.
Okay, 18 would be 1, right?
Yeah, right.
So maximum
No.
of, actually it's a maximum of what?
Maximum of
3,
for the top.
where t equals what? 18. So that's a maximum value. Are there any more maximum and minimum values here?
Well, the minimum would be 3 and 0.
Minimum of,
The minimum would be 0.
I don't see a minimum of 0. I don't see anything at 0.
It would be like 3/4 or something.
Yeah, 3/4. Minimum of 3/4
Max is 3.
So it's not all of them, it's just like the actual.
where t is equal to
Domain and range is
T equals
18.
13.
13.
Is it 13 or 18?
Okay, and there are any other ones here?
Why is the next 3? No. I think that's it.
Okay, you still have, you have a minimum of 1.75 where t is equal to 0, right?
Why is there 2 minimums if the other one is lower?
Okay,
Why is it 3/4?
and then there's another maximum of 2.5 where t is equal to 3. Okay, ma'am, what was your question again?
Why is it 3/4?
3/4.
Are you saying it's 3 or 4?
No, like 3/4 because right under 1 is where 13 goes.
Yeah, so she's looking at the graph here, and she's saying, she said 3/4 right here. So this is 3/4
Oh.
of a height, right? And people sometimes will put 0.75, right, which is the same equivalent. So she just put it in fractional form was all, right? So we have that. Okay, let's see, what else? What are functions, domain, and range? So that's going to be another person to be chosen here.
Is that max of
I still don't get why there's 1.75.
Okay, we'll talk about that then. Yeah, I don't know who Emily's chosen yet, but Madeline still has a question about this. All right. So she's asking why is there a minimum of 1.75? Because of this right here, that's a minimum. It's not a turning point, it's a local minimum, because right here, now there's nothing to the left, but over here, there's higher stuff, right? So it's not a valley, but it's the lowest relative point to this. So if I circled all this, that would be the lowest place there.
Okay.
There's no place lower than. So that answers your question. I mean, it would be the minimum for the same reason that this 3 is a maximum here, right?
Right.
That answer your question?
Yes.
Yeah.
Okay, good. Okay, who do we have?
Charlie.
Charlie. Okay, Charlie, 3. What are the functions, domain, and range?
I got the domain 0 is greater than or equal to x, which is greater than or equal to 18.
So he put an inequality notation, so 0, and if I might correct you slightly, Charlie, you said greater or equal to x, I'm going to put t here, because that's what they gave us, right? But it's the same, but he got it right nonetheless. And what is our range for this thing?
R equals 3/4, which is greater than or equal to half of y.
Yeah, it says v here,
Yeah.
yeah, which is
Greater than or equal to 3.
3. And he used inequality notation. I put interval notation here. But I hope that you are comfortable enough kind of going in between the two different ones. So anyway, so that's a good job, Charlie. You just nailed that one.
Nailed it.
Nailed it. Yes.
Where's the 0 from?
Where's the 0 from? Okay, let me tell you one thing that we talked about. In finding domain and range, what it is, it's like you take the graph of the thing and it's like smashing the graph of the thing up against the x-axis. You take this whole thing and collapse it down the x-axis. So you're starting here and going all the way to here, just kind of collapsed along the x-axis. So the x values, Charlie said x, right? But here's t. You're starting at 0, going all the way to t equals 18. Is that helpful? So you consider collapsing. And similarly, if you take the range, you collapse this thing, you start where y, or in this case v, is equal to 0.75, and go all the way up to v equals 3. So if you collapse back to the axis.
So like if the one had started at like 4, then 4 is less than or equal to 3.
Right, yeah, if this is started at 4. Here it's starting at 0.75.
Okay.
So yeah, that's right. Now, what happened is, in 6th period today, we were able to do these problems. We don't have time to do these ones in class today, but we're going to come back to these tomorrow, okay? Okay, good job. And let's see, who's left on the way? Okay, so we'll save her for tomorrow. So you might try to remember her. I'll try to repopulate the wheel. Okay, great, thanks.